Alright, so I was about to answer this question, which is, by the way, a great question. This is basically the main misunderstanding people have about matrices, and the main thing that's stopping them from understanding basis vectors connection to matrices. I was about to answer that, but then I realized that it requires a graphic example, which is convenient because, well, I have set up geometry nodes for it. So let's reset our basis vectors to the ones in the video, so all the most basic ones. There we go. We have 3 basis vectors in our more complex vector, let's call it. So we have the first basis vector, which has the coordinate of 1x, 0y, 0z, which basically means that it is just going right, okay, because it's just going 1 to the right. You have the next one, which has 0, 1, 0, which means it's going 1 forward, 0 to the right, 0 up, and the third one, which is going 0 right, 0 to up, and 1 0 to the right, 0 forward, and 1 up. Our basis vector in the video. Now, here's the basic idea of how vectors and matrices work. So here we have the coordinates of our matrice. Here we have a matrice. Here we have coordinates of a vector. Here we have our resulting vector. If we move our vector on the x-axis, what it basically means is increasing the size of the red arrow. If we move it on the y-axis, then what it basically means is increasing the size of the y arrow. If we move it on the z-axis, what it basically means is increasing the size of the blue arrow. And now what the matrix is basically doing is it's moving the basis vectors around, right? So let's move them to something a bit more complex, just some random values like this. There we go. Now we have our new vectors, right? Our new arrows, our new matrix, but the idea is still the same. Moving the vector on the x-coordinate changes the size of the red arrow. Moving it on the y-coordinate changes the size of the green arrow. And moving it on the z-coordinate changes the size of the blue arrow. So that's why, so that's the idea behind moving basis vectors into random spots, right? So let's make this into a bit, more of a mess, let's call it. There we go, a bit more of a... Here, there we go. Now it's a complete mess, and you can see that if I were to just move it around randomly like this, it's really hard to understand what's actually going on. But if I were to actually walk you through it step by step, that moving the x vector, moving the x component vector, scales the red arrow, and only the red arrow, that's the important part, only the red arrow. Moving it on the y scales the green one, and moving it on the z scales the blue one. Then I'm hoping it becomes a bit more clear. That's the idea behind the basis vectors and their connection to matrices and how vectors change. So this one kind of sets the basis vectors around, and then this first coordinate rescales this arrow plus this coordinate rescaling this vector, and then this coordinate rescaling this vector. Not gonna lie, I started recording this video right after I saw the comments, so I didn't prepare any script or anything. So yeah, I am stuttering quite a bit. It's really early in the morning, but the point is, this one rescales this, plus this one rescaled by this one, plus this one rescaled by this one, right? So if we increase x, so only this value, then the red arrow increases. If we rescale y, then this arrow increases. If we rescale z, this arrow increases, and we end up with a new purple vector. There we go, the purple one. Hopefully it should clear it up at least a bit.